What would happen if the Amazon rainforest dried out? A decades-long experiment has some answers. Libesi/Wikimedia Commons. Libesi/Wikimedia Commons. A short walk beneath the dense Amazon canopy, the forest abruptly opens up. Fallen logs are rotting, the trees grow sparser, and the temperature rises in places sunlight hits the ground. This is what 24 years of severe drought looks like in the world's largest rainforest. But this patch of degraded forest, about the size of a soccer field, is a scientific experiment, reports the Associated Press. Launched in 2000 by Brazilian and British scientists, ESCAFLR, short for Forest Drought Study Project in Portuguese, set out to simulate a future in which the changing climate could deplete the Amazon of rainfall. It is the longest-running project of its kind in the world and has become a source for dozens of academic articles in fields ranging from meteorology to ecology and physiology. Understanding how drought can affect the Amazon, an area twice the size of India that crosses into several South American nations, has implications far beyond the region. The rainforest stores a massive amount of carbon dioxide, a greenhouse gas that is the main driver of climate change. According to one study, the Amazon stores the equivalent of 2 years of global carbon emissions, which mainly come from the burning of coal, oil, and gasoline. When trees are cut or wither and die from drought, they release into the atmosphere the carbon they were storing, which accelerates global warming, creating drought conditions. To mimic stress from drought, the project, located in the Caxuana National Forest, assembled about 6,000 transparent plastic rectangular panels across 1 hectare, 2.5 acres, diverting around 50% of the rainfall from the forest floor. They were set 1 meter above ground on the sides to 4 meters above ground in the center. The water was funneled into gutters and channeled through trenches dug around the plot's perimeter. Next to it, an identical plot was left untouched to serve as a control. In both areas, instruments were attached to trees, placed on the ground, and buried to measure soil moisture, air temperature, tree growth, sap flow, and root development, among other data. 2 metal towers sit above each plot. In each tower, NASA radars measure how much water is in the plants, which helps researchers understand overall forest stress. The data is sent to the space agency's Jet Propulsion Laboratory in California, where it is processed. The forest initially appeared to be resistant to the drought, said Lucy Rowland, an ecology professor at the University of Exeter. That began to change about 8 years in, however. We saw a really big decline in biomass, big losses, and mortality of the largest trees, said Rowland. This resulted in the loss of approximately 40% of the total weight of the vegetation and the carbon stored within it from the plot. The main findings were detailed in a study published in May in the journal Nature Ecology and Evolution. It shows that during the years of vegetation loss, the rainforest shifted from a carbon sink, that is, a storer of carbon dioxide, to a carbon emitter, before eventually stabilizing. There was one piece of good news. The decades-long drought didn't turn the rainforest into a savanna or large grassy plain, as earlier model-based studies had predicted. Measuring forest recovery. In November, most of the 6,000 transparent plastic covers were removed, and now scientists are observing how the forest changes. There is currently no end date for the project. The forest has already adapted. Now we want to understand what happens next, said meteorologist João Thades, vice coordinator of ESCAFLR, a professor at the Federal University of Para and co-author of the Nature study. The idea is to see whether the forest can regenerate and return to the baseline from when we started the project. During a visit in April, Thades guided Associated Press journalists through the site, which had many researchers. The area was so remote that most researchers had endured a full-day boat trip from the city of Belém, which will host the next annual United Nations climate talks later this year. During the days in the field, the scientists stayed at the Ferreira Penna Scientific Base of the Emilio Goeldi Museum, a few hundred yards from the plots. 4 teams were at work. One collected soil samples to measure root growth in the top layer. Another gathered weather data and tracking soil temperature and moisture. A third was measured vegetation moisture and sap flow. The 4th focused on plant physiology. We know very little about how drought influences soil processes, said ecologist Rachel Selman, researcher at the University of Edinburgh and one of the co-authors of the Nature study, during a break. Escaflor's drought simulation draws some parallels with the past 2 years, when much of the Amazon rainforest, under the influence of El Niño and the impact of climate change, endured its most severe dry spells on record. The devastating consequences ranged from the death of dozens of river dolphins due to warming and receding waters to vast wildfires in old-growth areas. Roland explained that the recent El Niño brought short-term, intense impacts to the Amazon, not just through reduced rainfall but also with spikes in temperature and vapor pressure deficit, a measure of how dry the air is. In contrast, the Escaflor experiment focused only on manipulating soil moisture to study the effects of long-term shifts in rainfall. But in both cases, we're seeing a loss of the forest's ability to absorb carbon, she said. Instead, carbon is being released back into the atmosphere, along with the loss of forest cover.